This conference will now be recorded.
Okay, this project I did for a customer, and this one is to augment an FGCP cluster with a backup FortiGate. So we're going to be showing a option to use a backup FortiGate for two individual clusters. But in the end, just to give you a snapshot, in the end, the customer has found that it's easier for them to go a 2+1 model where you have an FGCP cluster and one backup standalone FortiGate. So each cluster will have its own backup FortiGate. And I'll discuss the reasons why I'm doing this and going through this. So let me just zoom in. Okay, this will work. All right, so the project objective, it's basically enhancing FGCP cluster resiliency. The background is mission critical networks require certain designs where traffic interruptions must be avoided. So this is for a customer that has mission critical environment, and we are trying to develop designs where there's no situations that can actually have traffic interrupted. So, and I'll show you in the lab how this works. Business needs, upgrade and test new firmware with minimal or no impact to production traffic. So the goal here is before upgrading the active primary cluster here, the FGCP cluster, this backup unit, we can upgrade to a certain firmware level, and then what the whole goal is to then start moving the traffic over through this backup FortiGate, bypassing the active cluster. And we can then determine if there's any issues with the new firmware, if traffic is being affected and so forth. And if you do see issues, we want an easy way to revert the traffic back to the original cluster state. So there's that business need. Backout strategy for firmware upgrades without impact to production traffic. Again, just discuss that is we have two ways of doing this. You can actually revert the traffic through this backup FortiGate and then upgrade the cluster, then revert the traffic back through the cluster. If there's issues, you can then fail the traffic back over to the backup FortiGate and then revert back and determine and troubleshoot why there's issues and so forth. Typically, firmware has a multi-level approach of upgrading, let's say from 6.0 to 7.x. You know, there's various levels that FortiGates need to go to, and also going back is just it. They're looking for a design where we can minimize the impact to the traffic as we go through these various stages of firmware upgrades. Also, the business needs are the ability to test new features and configurations with minimal effort to restore original state. So if I wanted to enable a certain feature on this backup FortiGate, I could then divert the traffic to this backup FortiGate, see how the traffic behaves and so forth, if the new feature is working as per our expectations, let it go for a while, and then I can then determine if I want to make those same changes on the existing cluster and then fail the traffic back over or revert back. So that's basically the business needs. Now, some requirements. We don't want any changes to the network routing environment, okay? So here's an existing cluster, a perimeter cluster. Here's an existing internal FGCP cluster. So before this backup device is added, you know, the network, the routing in the DMZ to the WAN and to the internal network, there's existing routing setups, static routes, dynamic routing, whatever it is, that's pointing and leveraging the cluster IPs of the various interfaces involved in the FortiGates. We do not want to, and one of the requirements was, I don't want to change anything in this customer's routing environment if I were to implement a backup FortiGate. Okay, so let me just do this. So when I implement this backup FortiGate, I don't want to do anything with routing. So basically, we're going to need to implement some sort of VIP that is going to take over the primary IPs of these cluster IPs. Okay, and then what else do we got? Manual failover to redundant FortiGates from the active FGCP clusters. One of the requirements was that I want to be able to manually fail this cluster's traffic over to the backup FortiGate, or this cluster's entire VDOM traffic over to this backup FortiGate. So the setup here is this example. I've got no VDOMs on this perimeter cluster, and I have a couple of VDOMs on this cluster. So this one has no VDOM, this one has a couple of VDOMs, and one of the requirements is we want to manually fail over either this entire cluster to this FortiGate, or a particular VDOM, an entire VDOM over to this FortiGate. So that's one of the requirements. What else do we have? So we have to synchronize sessions, obviously from both FGCP clusters to the backup FortiGate device. And we want to include all VDOMs, and we want the backup FortiGate to be managed separately. So this cluster here, by default, it's the root VDOM. I want all those sessions synchronized to this backup FortiGate in its root VDOM. And for our example in the lab here, I've got VDOMs 5 and 6. I'm going to put those on this backup device as well and synchronize those sessions as well. I'm not leveraging the root VDOM over here, and we'll talk about some of the requirements on that. So backup FortiGate managed separately, correct. So some of the assumptions we have to think about. We cannot introduce load balancer or dynamic routing to steer traffic to the backup FortiGates. So typically, when we look at designs like this where I have, if I go to here and I have a cluster and I have a third FortiGate, and typically we'll use a load balancer, or we'll enable dynamic routing to determine how the traffic gets steered. This was not a requirement here. This was actually, they don't want to purchase anything extra for the network. They don't want to change the network. We just want to implement some sort of strategy or solution design where this backup FortiGate can perform the tasks as we've identified already. We have to assume that this backup FortiGate will have enough ports, CPU memory sizing for all these connections and all the traffic that's going to be going through it. And basically one of the mandates is that I can only fail over one VDOM or one cluster at a time. I do not want to fail over both clusters at the same time. That's why it's important to have a manual selectable failover design. The backup FortiGate should have similar inspection profiles as the active clusters. Policies must match. So the policies, let's say on VDOM 5 and 6 on this backup FortiGate, which is an identical copy of the policies on these VDOMs here as well. So that's, basically what we're saying there. Logical port interface names need to match on the backup FortiGate versus the primary active clusters. So we need to ensure that every one of those VDOMs, those logical port interfaces are matching. And this is all in relation to ensuring that when we fail traffic over, the sessions are sustained and there's no interruption to traffic. And this is basically what we're trying to say here. All ports in a particular VDOM must fail over at the same time, and I'll discuss that in some additional slides. And VDOMs on both clusters must not be the same. So what I was saying is, because there's no VDOMs on this cluster, it's basically our root VDOM. So I've got this root VDOM on this backup FortiGate configured to synchronize and provide backup features for this FortiGate cluster. This particular cluster has VDOM 5 and 6, and we're not using VDOM root for anything at the moment. okay? And the backup FortiGate can have different FortiOS versions and can be a different model. So some of the assumptions there. So to do all this, what we're doing is we're leveraging FGSP. We are enabling VRRP to do the traffic routing, and we are synchronizing the sessions leveraging FGSP. And this link here is, and see if I can zoom in on that for you. This link here points you to a document that shows how all of this can be configured in bits and pieces. So I've kind of developed this design before I found out about this link. But basically, they have an example here of an FGCP cluster synchronizing sessions using FGSP to another FortiGate. And you'll find throughout the Fortinet documentation there's various types of examples of how this works. So yeah, so we're leveraging FGSP. You can see typically in an FGSP environment, we want some sort of router or load balancer to steer the traffic to either the active cluster or the backup FortiGate and so forth. We're not doing that. Part of the requirements was that we don't touch routing and we cannot implement a load balancer, so we're going to leverage VRRP. Okay. All right. So here is my lab setup for VRRP. I have a perimeter cluster with no VDOMs. I've got an internal cluster with a couple of VDOMs. So this VDOM here, which is the root, so no VDOM, is leveraging VRRP. I have identified my VIPs. I've identified the individual IP addresses of the various interfaces on the existing cluster and the backup FortiGate. This is the VIP. And then what's important is paying attention to VRRP groups. So I am using VRRP group 10, the same 10 here and there. So when I fail a particular interface on this cluster, it fails over the VRRP and becomes active on this backup device. Same thing here. I've got two VDOMs, VDOM 6 and 5. I'm using VRP group number 1 for this VDOM, VRP group number 2 for this VDOM. I've got my VIPs identified, and what I'm saying is I want to be able to fail over an entire VDOM in this cluster and have the traffic be processed in VDOM 5, let's say, in this backup FortiGate. I can do both VDOMs, so I can do this entire FGCP cluster, but I do not want to do both clusters at once. And there's reasons why I want to fail over a particular entire VDOM at once in this cluster instead of one interface existing over here and then the other interface on that same VDOM over here. We run into some sort of traffic anomalies and it's just not clean. So an entire VDOM at any one time is how I've decided to implement this. And these are just the interface IPs of the various FortiGate interfaces in the particular VDOMs, and we have our VIPs identified here. And so we'll go into that configuration. And then we have to synchronize the sessions. With that, we're leveraging FGSP session synchronization, and this is just depicting I need connections, either layer 2 or layer 3, between this cluster and this backup FortiGate, and this internal cluster and this backup FortiGate. So I basically have a layer 2 network in my lab, and I've got the IP addresses identified here, where I've got this root VDOM. So this FGCP cluster with no VDOMs is leveraging IP interface that's identified as 172.18.1.1, and it's synchronizing to the root VDOM on this backup FortiGate, and we're pointing the FGSP synchronization to that .2 address. And same thing that happens for these particular VDOMs. So VDOM 5 has 172.19.1.1 for its local interface on that VDOM that we're using for session sync. It's again connected to the same layer 2 switch, and it points to 172.19.1.2. and vice versa. So we have all that configured in FGSP, and I'll end up showing that to you. But in the end, what ended up happening is it's a much cleaner design to go a 2+1 design if you're interested in mission critical networks where you can be able to do certain things with a backup FortiGate without impeding the cluster itself.
This conference will now be recorded.
Okay. So here is my lab environment where I've got my perimeter cluster right here, and it's these two FortiGates. I've got my internal cluster. So my internal cluster is down here. And for lab's sake, I just have a single FortiGate. I could obviously have another FortiGate here in an FGCP cluster as I shown here. But for this particular lab, I didn't really think that was necessary. So what we're showing is, let me just go back to here. So my perimeter cluster, my internal cluster, which is just a single FortiGate. And then here's my backup FortiGate, which in this world is right here. Okay, so that FortiGate is there, which is right here. Okay. I'm going to erase everything and then keep moving forward. So the goal here is I've got some local interfaces off of this internal cluster. So I have some interfaces on VDOM 5 and VDOM 6 as identified down below here. I've got those same VDOMs 5 and 6 trunked to the DMZ network. And then I have this FGCP cluster as a perimeter cluster with no VDOMs. And then I've got connectivity to my WAN. In addition to all this, I am pushing traffic load using FortiTester. So for the purposes of the test, I'm going to be pushing traffic from FortiTester through VDOM 6. It'll go out this way, go out active, and then go that way. So you'll be seeing FortiTester, and then what's going to happen is I'll end up either failing this link or failing this link, and what we'll end up seeing is traffic start to go this way, right? So that's going to be one scenario, and then there's going to be other scenarios where I'm going to have traffic produced this way. So we're going to go this way. It's going to end up coming this way and then going out that way. So if I fail VDOM 6, then if I fail VDOM 6 on this cluster, traffic will then start reverting to the backup FortiGate over here. And yeah, it looks a little messy here, but all these connections are providing the connectivity as I described in the Visio diagram. So I've got my session sync. So here's my layer 2 switch, and I've got my various links from the various VDOMs synchronizing the layer 2 connections and my various IP addresses for the various interfaces. So, and you'll see that FGSP configuration. But the first thing we're going to do is just look at the FortiGate. And so let's look at the primary data center. And so the perimeter cluster, let's look at this configuration for VRRP. So let's just show you that. So in here, so I go into here and I can see my various interfaces and I can see my VRRP. So this is my WAN interface, and pay particular attention to some of these configurations. So I can see here that this port 2 has an IP address of 20.1.1.3. I have to set this command to start using VRRP. I have to config VRRP, I have to edit an entry. I'm setting my group to 10. I'm setting my VIP to 20.1.1.10, and I'm setting a priority. Okay. So that's the WAN. If I go back to here, I look over here, this kind of tells you that that's what I just showed you there. So if we look at this side of the interface on the 30 network, here's the 30. So this is port 10. So port 10 is facing downward, and if we go to here, this is the port 10 interfaces, and in an HA FGCP cluster, I'm using port 10 here, and I'm using port 10 here to my layer 2 switch. So let's go back to that. We can see that this particular interface on this FortiGate is 30.1.1.1. So we can see here that I'm using that, and I should have my VIP set to 30.1.1.3. And my group, again, is the same group as this one, which is 10. Okay. There's my group, there's my VIP, and there's my priority. So these priorities are very important. So if I get router info, VRRP, we can see here that we can see the state of the port 2 interface, which is this IP. And I can see that my actual VIP are configured accordingly, as we've shown from the CLI. And what we can see is the priority level is 200 here and 200 there. And I'm going to show you the backup FortiGate, but you'll see why this is master. Okay, this is group 10, and this is group 10. So just as an example, if I were to fail any of these one interfaces, so if I fail that interface, I can go back to here and now show that both of them now have been put into the backup state. So let's go back to here and we'll re-enable this. And now, because of how we have VRRP set up with priorities, this should become master, and it has. So now let's go look at this backup device in the root VDOM, because this root VDOM is what's being configured as a backup for this entire cluster. And again, if we look at my diagram here, this is where we're going to go into this particular device now and look at its state. Okay. So now if I config okay, config says, actually before I do that, get router info. You can see here's the other IP address, and we're all talking about the same VIP. We're all using VRP group 10, and now you can see that I'm priority 50 and priority 50. So what I've done here is I'm saying that this particular interface, which is 20.1.1.2 and 30.1.1.2, have a lower priority, so they will not become the master VIP, the master router responding to this particular VIP or this VIP. Okay. And again, if you can see that it's in backup state, so if we go back into here and I disable or suspend those interfaces, I can now show that it's now in a master state, and that means that traffic has to be routing through this FortiGate. And I'll demonstrate that in a bit. So if we go back into here, I can look at this. I can look at my primary side, and we can see it is in a backup state. So if I go back to here and I re-enable this, it's now going to have both of them into backup. Right now, one of them is. So based on the timers and stuff that we can configure in VRRP, we can make that quicker or slower. But we can see now that they're both VIPs are in backup state. So both of these interfaces for this particular VIP and for this particular VIP are in a backup state. Okay. So that's this perimeter cluster, this FGCP cluster without any VDOMs being backed up to the root VDOM on this backup FortiGate. So let's now go to the internal cluster and look at the VDOMs 5s and 6. And if we go to here, that's this particular FortiGate, and we have VDOM 5 and 6. We have the various VIPs that have been configured for the interfaces. So I've got these interfaces that are pointing to the DMZ. They have their VIPs configured on their associated interfaces. So each FortiGate interface has its own IP, but both sides have the VIPs and the groups set accordingly. Okay. So if we go to here, if I config VDOM and if I edit VDOM 5, get router info, we can see that I'm saying this particular FortiGate has an IP address of 10.1.1.2 on this interface, which is a VLAN interface. I am saying that on this particular port, I'm having this IP address. Here's our VIPs right here and right here. Priority of 200, 200, which is higher than the priority 50 we see on the backup, and we'll show that shortly. And I'm using group 2 for this particular interface and group 2 for this. So when I fail one of the interfaces, all of the interfaces that have VRRP configured with group 2 will then go into backup state. So if I go into here, and let's just say that I fail this VDOM 5 interface, which is port 4. So let's go to that. So now we see that both the VLAN interface and the port 4 interface have gone into a backup state. If we go to the backup FortiGate, okay, so if I show you the picture now, so I have failed VDOM 5 and only VDOM 5. All the interfaces on VDOM 5 have failed over. And now on this FortiGate here, it should be master. Okay, so if I do this, you'll see my root on that one is still backup. And now it's a master on this particular VDOM. So VDOM 5 on the backup FortiGate is now active. And if I config VDOM, it's backup for VDOM 6. And if we go to, if I go back into this particular FortiGate, so going back into this FortiGate, I should look at my VDOM 6 and ensure that it's still active, which it is. So we can see that right here, this interface is disabled, which is on VDOM 5. It has disabled interface 5 on this tagged uplink, but these interfaces for VDOM 6 are still active. Okay. So let's go back and let's go to that one, which is here. And we need to clear that. And VDOM 6 shows that the interfaces on this particular FortiGate are active. So all we've done is failed over VDOM 5, and we can see that only VDOM 5 interfaces have failed over to this backup FortiGate. So what does that mean? That means that traffic will be flowing right now from this device, if it were communicating out, through here, and then back through this interface, and then out the active links. Okay. And let me just go back to normal mode. And if I go back into here, I can resume that, and then VRRP will kick back over. So config VDOM 5 get router info VRRP. It's now master again on VDOM 5, and this is this bottom internal cluster FortiGate here. So what we did is we're able to show you by disabling a link here or a link here using VRRP, this backup FortiGate becomes the master and therefore will be responding to routing of the VIP IP. And so that's how we get the traffic to start moving from this particular interface out to the backup FortiGate and vice versa. Okay. So let's look at a little bit more of the config. So here's the configuration on the internal cluster. So this screen here is this FortiGate. Let's just take a quick peek at its VRRP config. Okay, so here's port 4, VDOM 5, that's the IP. And we have this, obviously this command enabled. And we have VRP group 2 and priority 200. Okay. And the same thing happens for VDOM 6. We have for this particular interface, and we can just continue on down the line showing the various interfaces and the various VDOMs and their appropriate groups. So reviewing here, anything in group 1 would have gotten failed over if I failed any interface in VDOM 6, and the same thing for VDOM 5. Okay. So that's really VRRP and how it's using the configuration of VRRP with priority level to determine who's master and who's slave. So if I go into the backup device, which is here, if I config sys enter and I show my interfaces, you can see here for VDOM 6 or for my root VDOMs, you can see that my priorities are all 50s. So those are lower than the 200. Therefore, all the VDOMs and all the interfaces on this backup FortiGate, which is this one here, is always the backup for the VIPs. Okay, so if we go to here, this FortiGate here is the one that's always, these interface IPs are the ones that are always going to be in backup mode, and the master interfaces, the active ones for VRP, will always be on these active clusters. Okay, so what we're going to do is talk about one last thing about VRRP, and that is I wanted to discuss the virtual VRP MAC address. So if we look at the VRP information on this particular FortiGate. We can see that I was setting this command, set VRP virtual MAC enabled, under the particular interface. So every interface that we're configuring VRP, I want to discuss what the virtual MAC address for VRP does for us. And so you can see it has a following format when you enable this. So each VIP will take this format, which is that those first few octets plus the VRP ID. So each of the VIPs, no matter which FortiGate is the master responding to the VIP, that master will always take over and use that particular virtual MAC address. And hopefully you'll be able to get better response times and so forth when doing failovers between the master and backup VRP routing interface. So the format is as we see here in the documentation, and then it's very important that we then consider looking at how we've configured the VRP router ID. And it's really just the ability to then add that router ID to the end of those octets. So if we look at this, we can see there's that the first part of the virtual MAC address is all the same except for the last part, which is correlating to your VRP ID. So in that instance, it's 5, and in port 2 there, it's a VRID of 1, which corresponds that to the virtual MAC address as well. So when we look at that, we should then see that on the backup VRP node, those virtual MACs should be the same. And it's as simple as selecting and configuring with the same VRP ID. So now we're on the backup node, and we can see that it's in backup states, and we're also leveraging the same VRP IDs when it was locally configured. And we can see that these MAC addresses match. And so, the whole goal here is to identify that when this backup VRP node takes over to responding to the VIPs, that the client stations or anything leveraging that MAC address does not have to re-ARP for the MAC address of the VIP. And so this, in the end, makes failovers much more efficient and much more quicker. And that's the whole goal here. So if I look at here on port 10 on the backup FortiGate, I've leveraged the same VRP ID. And so when we go into that, just wanted to show you that the VRID is what correlates to that number 5 in the config. When I did an edit 5, that number identifier becomes our VRP ID. And so when we configure this on either side, we want to make sure we want these IDs to match. And that's how we end up having the virtual MAC addresses be the same for whichever side decides to respond and elect itself as the master and start responding to the VIP. So each of these interfaces correlating on the primary side and the backup side, so the master side and backup side, they will in theory have, not in theory, but they will have all the same virtual MACs responding for those appropriate VIPs. Now, if we look at the VDOM, so we're going into VDOM 5 here, let's just verify that. So we can see here that we're leveraging, was it VRP ID number 1, and we're looking at the primary VDOM interface on the internal cluster, and we're going to, that was the backup we were looking at on the CLI, and we can then look at the internal cluster's actual VRP information just to compare. So this is the the backup VDOM 5. And if we look at the internal cluster and we configure into VDOM and we go edit VDOM 5, Sorry, that should be VDOM 5, not 6. And if I look at VDOM 5, and again, we compare the virtual MAC, so let's go do that. We can see here that my VRRP IDs should match between the backup side and the master side, which they are. And we can see whichever side becomes a master and starts responding to that particular VIP, we will start leveraging those virtual MAC addresses, again, making failover a lot more smooth. So now if we look at a client in the DMZ and we want to demonstrate in the ARP table what that's going to look like when we start communicating to the VIP. I have a browser client in the DMZ, and what's going to happen is we're going to initiate some pings, let's say, to the VIP of 30.1.1.3, and then eventually what's going to happen is we will fail the master over to the backup FortiGate and demonstrate the MAC addresses. So here's the client. We are going to ping the VIP, which is 30.1.1.3, and that is just fine. So we're in the DMZ there. We're pinging the VIP, and this perimeter cluster, FGCP cluster, is the master at this point. And as we fail over, we will see the backup become master, and it's then going to continue to use that same virtual MAC address. So stop the ping, we'll just take a look at the ARP table. We can see there's that MAC address that we saw in the CLI. It's responding accordingly with that appropriate MAC address. So if we stop that interface on the master, the backup FortiGate now becomes a VRP master and starts responding to the VIPs. And let's just go back into root and verify that. So we're on the backup FortiGate. And if we go into the root VDOM and we look at our VRP state, we can see now that this backup FortiGate is the master. And what will happen is if we're leveraging, let's say, communicating to 30.1.1.3, that virtual MAC address will continue to be responding with that particular MAC address. So again, we can see that 30.1.1.3 is responding to the client in the DMZ, and that's working fine. And now if we look at the ARP table, we can see something interesting. So 30.1.1.3 MAC address has not changed, but there is 30.1.1.2 now in our ARP table. And that obviously was used in the background between the client and the backup node, which is now the VRP master, and that ended up going into the ARP table. The specific mechanics around why that happened, I'm not sure, but it does make sense since that is the actual node. So let's resume that interface, and what we'll see now is that the backup FortiGate should then go into backup state, which it has, and we'll just look at the primary side and the master. It is in master state. So that should still continue to be pinging. And then what should happen is let's initiate a failover and have the backup take over the master role and start responding to the VIP. And we saw a little bit of a 1 millisecond blip there, even a 2 millisecond blip. And now it's responding from the backup side. We didn't lose any traffic. And let's just make sure that it's responding. So we demonstrate that, showing that the backup side is now the master for those VIPs. So the backup is now responding. And our response time, and we haven't really missed anything, but our packets haven't dropped. I have now failed over from the backup back to the left side, which is the perimeter cluster. We can see that the backup now is in backup state for the VRRP state, and we did not lose any packets as we then reverted the traffic back over to the left-hand side, which is the perimeter cluster. Okay. So I'd like to quickly talk about FGSP. So we've initially talked about VRRP. Now we want to start talking about how we're going to synchronize sessions to the backup FortiGate over here on the right-hand side. And, we're just showing the specific interfaces that are going to be used for the FGSP cluster synchronization. And the various VDOMs have their own cluster capability of synchronizing and configuring FGSP to the backup node. So if we look at this, I can show you that my two VDOMs in the bottom internal cluster there has its layer 2 connection to this layer 2 switch over here that's receiving all the FGSP links that are dedicated for synchronization. Can be layer 2 or layer 3, it doesn't matter. This is just for our lab example using a layer 2 switch. And each of the VDOMs have this configuration. So we can see that to enable FGSP, it's a simple set peer IP and the other side, the remote IP address of that connection. And that starts to synchronize sessions. We also want to start augmenting what sort of information that we are synchronizing. These next three sections of commands there benefits FGCP and FGSP at the same time. So obviously we want to synchronize NAT sessions. We want to synchronize UDP and ICMP sessions, which a lot of applications leverage UDP and ICMP that we really can't see easily. So it's good to always enable that. And then asymmetric sessions as well by using those commands at the bottom there as well. And that's done under config system HA. So we have all that configured, and let's just see if we can go into, so that's the perimeter cluster at the top. And we can just show you that the FGSP, so the cluster sync, is going to be from our side, 18.1.1. We're going to be communicating to 18.1.2 to the backup FortiGate. We can see that there's some sessions here existing on this perimeter cluster, approximately 38 there that are active at the moment. And so let's just go and compare after we show where we enabled this, which is config system cluster sync, and then I'm setting the peer IP to the 18.1.2 IP address on the backup side. So to show the cluster sync config, we actually have to do that in global. So any FortiGate that has VDOMs, we have to configure global and go into it, and we can see that it's all done for all the VDOMs in one particular global location. And we can see VDOM 6, we can see VDOM 5, and number 2 there is the actual root VDOM, and since root VDOM is the default VDOM, it will not show up when we do a show command. So we do have root from the perimeter FGCP cluster configured here. We have the peer configuration for VDOM 6 and 5 that is pointing to the IP addresses on the internal FGCP cluster here. Obviously, we do not want the root VDOM from the internal FGCP cluster to be synchronized to the backup FortiGate because that will conflict and it just does not make sense. So obviously there's caveats to having to do this particular design, and we have to make sure that the VDOMs do not overlap. So we're looking here at the internal cluster. We can see we are only synchronizing VDOM 5 and 6, and we're not doing the root VDOM. So as you can see that they match up, the IPs are matching, they're pointing to each other, and it's purely just a very simple session synchronization that have been done here. I've disabled the IPsec tunnel sync configuration because for my lab it's really not needed. But I think by default that obviously by default that command is enabled and encrypted in an IPsec packet. So now we're just showing again that this root VDOM at the perimeter cluster has to reside on the backup FortiGate there, and we're ensuring that the internal at the below FGCP cluster does not have its root VDOM as part of the FGCP session synchronization. And it's obviously a little bit more of a complex configuration to do two clusters backing up their sessions to one particular FortiGate. But it is actually supported and acceptable. So, and we can see that VDOM 5 and VDOM 6 have their sessions configured to synchronize to the backup, and we're saying at the root there at the top. So from 18.1.1 to 18.1.2, that's the root VDOM being synchronized. Okay. Just reviewing some of the configuration and the internal versus perimeter cluster, making sure that information is now going to start synchronizing. And we're now going to go into the VDOM and look at some of the sessions on the root VDOM. So this window is the perimeter cluster, and let's just look at our sessions, and we see that there's 31 active sessions. Now on the backup FortiGate in the root VDOM, if we do the same sort of command, we have approximately 15. So not all the sessions on the active side will get synchronized over. There are certain sessions that just stay local that are not going to. So you'll see a little bit of a discrepancy as you start to dive into the actual session tables and compare what's being synchronized over. But as traffic passes through the FortiGate, those sessions absolutely are synchronized over. And so we're just looking at, okay, we're just showing you, yes, there's a lot of similarities between the session tables. So we know that FGSP is synchronizing the sessions. And obviously to prove that, we're going to enable some simulated traffic and show the session tables to see how they're actually getting synchronized over. So how are we going to do that? We're going to leverage Fortinet's product called FortiTester. And so I have two ports of the FortiTester. One port is in VDOM 6 below, and port 2 for that FortiTester is located in the WAN here. And so I've got those two ports configured to talk within my GNS3 world. And we're going to initiate a throughput test between port 1 and 2, and then we're going to show the sessions that are going to start get synchronized over to the backup FortiGate. Okay. And then obviously eventually what's going to happen as we do this is we're gonna fail the perimeter cluster and have the backup FortiGate take over as VRRP master, and we'll show how the sessions react to that as well. So again, that's the path right now as things are active with the VRRP states and how the FortiTester is going to start sending its data. And we'll see what happens after we look at the session tables and start failing things over. So we'll just clear that up. We'll go log in to FortiTester, and let's just see what we'll just show you what's going to happen here and what a basic throughput test is looking like on FortiTester. So we go into the performance tab, Obviously, I've done this a few times, so there's some predefined throughput tests. And this is already configured for those two interfaces to talk to each other and configure with the appropriate IPs and configured to communicate within GNS3. And so now we're going to initiate this throughput test. And it always takes a little bit of time to start. And once it starts, we can see the traffic is starting to traverse through our network. Okay, we can see the throughput here. So we know that there's packets that are communicating through our network here, our lab topology. So we can also verify that by the number of sessions on our FortiGates. So this is the perimeter cluster, and let's go look at the number of sessions now. Previously it was in the 30s, and now we're at 326. So we can also take a look at what are the IPs that are communicating, and we'll see that the 18.2.1 subnet, that's part of the communication of FortiTester and the IPs that have been associated to FortiTester's interfaces. So we know that this is the FortiTester traffic going through. So let's go to the backup FortiGate and we look at the session synchronization. Let's look at the session table of this backup FortiGate now. So in theory, FGSP should be doing its job by synchronizing the sessions over to the backup FortiGate. So if we do this again, we can see, yes, we're back up into the 300 session count. And so that makes sense. And we can see the same IPs for FortiTester are being used, even though none of the traffic is actually passing through the backup FortiGate. The session tables are synchronizing. And we can see a mixture of TCP and UDP traffic as we traverse through, just as it was on the left-hand side as well. So I just want to show you in the HA config, those additional commands that we spoke about previously are enabled, and that then helps us to have a more seamless failover to the backup FortiGate that we are synchronizing sessions to. And so if we look at the VRRP state, we know that this side is the master, and we look at VRRP on this side, we're going to make sure it's in backup state, which it is. So let's see now what's going to happen if we try to fail the traffic over now. And so we're going to take down a particular interface on the perimeter cluster that then forces the VRRP to become active on the right hand side. And we'll see that move from backup to master state, and the traffic now will then start traversing this way. Okay, so this is how we want to ensure that we're bypassing the active FortiGate cluster and look at how traffic is being affected when we fail over. So the whole idea here is we are going to see a blip in the traffic. We're not losing and stopping any sessions from communicating or traffic. It did take a blip in throughput there, but then we're back up to traffic continuing on. So it was a very, very minimal impact at all to traffic, if you even noticed it at all. And we can see that just to prove that it is going through the right hand side, which is the backup FortiGate, we looked at the VRRP states and they're fine. And yeah, it's back to its throughput of 10 meg. And we really didn't see any sort of traffic drops or anomalies other than that that little blip in the throughput itself. So when we resume this, we're not going to actually see any blips at all in the traffic because the session tables are synchronized, and the traffic really does not have any need to be impacted at all. The sessions are pretty much identical between the two FortiGates. We can see that the traffic did not get affected. I go to my primary side, my primary cluster, it's the master. My backup is now back to being backup. And this proves that the traffic is now traversing through the normal expected route. So if we actually log in to the GUI on the FortiGate, we want to verify some of the requirements, which was looking at policies. We want to match the policies as much as possible. If we look at the FortiGate here, the perimeter cluster, the reason why that the failover happened so well is one of the requirements is you should have identical policies. And you know, the caveat is here should. They don't need to be 100% identical, but the 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 more acceptable or the more closer they are to each other between FortiGates, the better the traffic performance will be when you fail over. And if we look at some of the requirements that we discussed earlier when creating FGSP, you know, we have to have the VDOMs identical on the members. Logical interfaces used for traffic policies must match. And there's the last bullet there. It says identical policy tables should be used. So, you know, it's in should be used. So that means that you can have different configurations for policies on both sides. Just, you know, expect that traffic may be impacted a bit. And so if we're looking here at the primary perimeter cluster and its basic policy configurations, and if we go to the backup FortiGate and look at its configuration, we should see very similar policy configurations between those two FortiGates. But in my example, I have one policy that is a bit different. So we go into the root VDOM and I look at policies. We can see here that the top policy is identical, but the from port 2 to port 10, I've got a couple of security inspection profiles enabled just to see how it would be affected during the failover. And what we're going to end up doing is disabling that to look identical to this one on the perimeter cluster, and to show you that the failover obviously is still unaffecting traffic at all. But we can see we did fail over. We did see that this particular backup FortiGate had a different security inspection profile, and traffic was barely affected, if not at all. So let's go and just make them identical now and take a look at the failover with FortiTester and see how it affects it. So we have to actually you know, go into the policy itself, and let's go and disable these security profiles. You can do it here obviously by hitting edit or just double clicking into the policy, and let's deselect these profiles. We have to hit OK first, and then we can go back and change our SSL inspection to no inspection just to match both sides here. So we go to the bottom, we pick that, and now the policies are identical between the backup and the primary side. And now if we go to FortiTester, it looks like it's still running. We have a little bit of time left there. So let's quickly go back into GNS3 and initiate a failover and force the backup FortiGate to become the VRRP master. So we did that. We can see that traffic then starts to be affected again, and then it's back and working again. So traffic takes a little bit of a hit, but it really you're not losing connections. You're not dropping any traffic that we can see visibly, but it's a It's a very quick failover with minimal impact, if any, to the traffic flows itself. And obviously we can fail it back and it shouldn't affect the traffic at all. So that still is performing well. And yeah, traffic reverted back and we're doing good. So none of the traffic was affected. And we're going to just ensure that that's in the master state. And we can see the backup is in backup state. And so everything is back to normal and communicating fine. Okay, so let's look at VDOMs 5 and 6 now. So we're going to look at VDOM 6 because that's where FortiTester is sending its traffic through. And if we look at the session table, we have 165 sessions currently that is traversing VDOM 6 in the internal cluster. And if we go into the backup FortiGate here on the right hand side, and we look at VDOM 6 and we look at its session table, you know, they should be pretty similar. So yeah, we can see that those sessions during that transfer was actually occurring, and it's about 150. So there's always that little discrepancy between the quantity of sessions. So now we're going to look at VDOM 6 that is sending its session synchronization to the backup FortiGate. Because we have our FortiTester is connected only to VDOM 6 interface in the GNS3 world. So if we rerun this test in FortiTester, because it did finish, if we reinitialize and start the throughput test again, we want to look at how the sessions are now going to be synchronized in the bottom part of our diagram. So yeah, let's just minimize the primary one. Let's look at the internal cluster and the backup cluster. And if I look at that, I'm up to 539 sessions now. And if I look at the backup FortiGate in VDOM 6, you know, we're getting up there. It's the counts for the sessions are getting near to what we see on the active side for the internal cluster. So looking at how traffic is performing, we can see that yeah, things are traversing fine like we did before. But this time we're going to fail VDOM 6 and have the traffic start traversing through the backup FortiGate. And we can see here there's always that little blip. And then what's going to happen is the backup FortiGate is going to take over and become the master. And since the sessions are synchronized, we can see that traffic is continuing through. And we also noticed that now the traffic is going to take this route to go out to the other port on the FortiTester. So again, obviously the way that I've designed this is I only want one failure to happen at any one time. And this red line is the normal route when both sides on the left are in the master state. And we can see that now because I failed that VDOM, that traffic is now going through the backup FortiGate. And it still has 472 sessions. The backup side's got 468 active sessions. And let's just verify from a VRRP perspective that yes, the internal cluster is in a backup state and the backup FortiGate is in master for VDOM 6. Okay. And you know, part of the caveats was that I do not want both clusters failed over at the same time to the backup FortiGate from a resourcing point of view. So that seems to be working just fine. And we can see that it actually got a whole lot better throughput when I'm going through the backup FortiGate and bypassing VDOM 6 on the internal cluster. And that's just anomalies within GNS3 in my virtual world and my virtual FortiGates and resourcing and so forth. I'm actually getting much better throughput going through my backup FortiGate itself. So let's re-enable this and let's just see how traffic then starts to get reverted back to the internal cluster now instead of going through the backup. And we can see that what's going to happen is it's going to eventually start to settle at about 10 megabits per second. And we know now that it's going through the primary FortiGate, so the master VRRP node on the internal cluster. And it has a throughput of about 10 megabits per second there. So it's for sure traffic is sent over, and now we're back to this original traffic flow between port 1 and port 2 on FortiTester from VDOM 6. And we can just verify that this is now the master in VDOM 6, and on the backup, it's in backup state again. So that really shows you that with session synchronization and VRRP enabled, we can do the failing over between the primary and backup sides without, any impact to traffic. If there are, it's so minimal that we can't notice it. And that's the whole goal here, was to demonstrate the failing over of FortiGates from one cluster to a backup FortiGate from particular VDOMs and so forth, to demonstrate that we can do certain things as outlined originally in our requirements. So this is eventually what this particular project customer felt more compelled to do, which was a 2+1 scenario. So instead of having one FortiGate for both clusters, they're considering one FortiGate now per cluster, which is a lot cleaner and easier config. And from a resource allocations, we can obviously not have to worry about failing over 2 clusters to 1 unit. It's each cluster has its own backup FortiGate. And this was something that we needed to test out to ensure that it was feasible, and it is, by having both clusters with multiple VDOMs failed over to one FortiGate, which works just fine. But they chose to go or consider a 2+1 scenario. So just to review, we've identified and ensured that we've met all the requirements and business requirements, and we've ensured that we've adhered to all the requirements outlaid and a lot of the assumptions that were made, and some of the FGCP requirements that were identified were also implemented. So this was the design that was pretty successful, and hopefully it helps someone. Thanks.